This lesson is on 3.6, which is piecewise linear functions. So piecewise functions, you can think of, it is a function made up of pieces. The pieces are usually given by two or more different equations. And then right next to each equation, there is an interval of the domain values they actually want you to use for that particular equation or function. So for the first piecewise, we have two equations here. We have x minus 3 and 1/2 x plus 4. For x minus 3, we are only plugging in these x's. So we can only plug in from -3, and it can be -3, all the way up to 0. And we can't include 0, but we're going to get real close to 0. So even though we can't include 0, we still want to actually figure out what the output would be at 0, so we can do our open circle on our graph at that number. So remember, a quick review, if it's a closed circle, it means it includes that point. If it's open, it doesn't include that point, but it gets right up to it. Okay, so if it's an open circle around 3, then maybe it goes to like 2.9999999 forever, right? But it doesn't get to the number 3. So when we fill out this table, we are going to mentally have to figure out what the output for 0 would be, even though we're not going to put it on the table because it doesn't actually include that output. So I'm actually going to draw, and you might want to do this because it will help you remember to switch which function you're plugging your inputs into. So this one goes up to 0. It doesn't include 0. This one actually is where you include 0. So I'm going to do a little squiggly right here because that's where I'm going to switch which function I'm plugging my inputs into. So at -3, I'm plugging it into the top equation. So -3 minus 3 is -6. Then I'm going to plug in -2. -2 minus 3, -5. -1 minus 3, -4. And here's where I'm going to switch because I drew this line, so it tells me, okay, I'm going to actually switch who I'm plugging into because this one can't include 0. This one can. So I'm going to plug 0 into this one. Half of 0 is 0 plus 4 is 4. Half of 1 plus 4, that's 4.5. Half of 2 is 1 plus 4 is 5. Half of 3 is 1.5 plus 4 is 5.5. Half of 4 is 2 plus 4 is 6. Now notice I did not plug 0 into the top function, but in my head I'm saying to myself, well, what would 0 give me? 0 minus 3 is -3. So at -3, that's who I'm going to put the open circle around when I graph this. So plot the point, -3, 1, 2, 3, 4, 5, -6, -2, -5, -1, -4. So those are all closed dots or closed circles. And then I am going to plot 0, -3, but I'm going to make it open. And when I connect those, you're going to go right up to the open circle. Okay, and now I'm going to plot the other ones, which they do include from 0 to 4, so I don't have to worry about any of them being open circles. They're all going to be closed. So 0, 4, 1, 2, 3, 4. I'm only going to actually plot the points that are integers because really you only have to plot enough to see what's happening. So I'm not going to plot 1, 4.5. I'm going to plot 2, 5. Then you would have 3, 5.5, and 4, 6. And then you connect those. Do not put arrows on the ends because it does not go on forever. You're only going from 0 to 4 and then from -3 up to 0. All right, part B says state the range using interval notation. Remember, that's with these guys, right? So our range, you always start with the lowest. We always usually talk about the lowest first up to the highest. So the lowest range, the lowest y value, is at -6, and it does include -6. Well, if you start traveling up, you agree the highest up here is at +6, but there's a big gap. Look at this gap here. those numbers are not included in your range. So you need to actually write two parts to your range. You're going to write that your range goes continuously from -6 up to -3, but it doesn't include -3, so make sure you put the curved parentheses around it. And then it's what we use this like U looking symbol. It means unioned. Okay, so that's the union symbol. So it's this interval unioned with, my range picks back up at 4, and it includes 4, and the highest it goes is 6. So this says that the range is from -6, including -6, up to -3, but not including -3, unioned with 4 to 6. C says, take each individual linear equation and find the x-intercepts. So remember, x-intercepts, when you're finding the x-intercepts, that's when the y's are 0. So I'm going to take each equation. So the first one was x minus 3, and I'm going to set it equal to 0 and solve for x. So I add 3 over, so that x-intercept is 3. The other equation I'm going to set equal to 0, 1/2 x plus 4. Subtract the 4 over, and then multiply by 2, so you get x equals -8. So there's your two x-intercepts. Well, you'll notice on your graph, part D, it says, why does your graph contradict the answers you found in part C? I don't see the x-intercepts on my graph. These do not have x-intercepts at 3 and -8 like it says they should. So what that means is that there are no x-intercepts due to the restricted domain given by the piecewise function. So you would just write something like, there are no x-intercepts due to the restricted domain in the piecewise function. And that's it for lesson 3.6.